All right, back in chapter 13, we are on slide 24. I already did the first problem in the PowerPoint, now I'm on the second one. So it's asking me to find the molality of a solution that contains 2 grams of glucose in 25 grams of a solvent. It doesn't tell us which one it is. So, molality is the moles of the solute, which in this case will be glucose, over the kilograms of the solvent. So, should be pretty simple. The moles of glucose, they gave me 2 grams. If I divide 2 by 180 is the molecular weight, that's going to give me my moles, which I believe, let's see, is 0.01111. Divided by the kilograms of the solvent. The solvent I have 25 grams. Switch that to kilograms, it should be 0.025. So now if I divide my moles of my solute divided by 0.025 kilograms, that's going to give me 0.4 repeating. So I'll call it, for sig figs, looks like I should have 3 sig figs. So 0.444. Little m for molality, make sure it's not a big M, because that's molarity. C6H12O6. That would be my answer. All right, moving on to the next problem. Wants me to calculate the molarity of a solution if it has 5 grams of toluene, so 5 grams of C7H8, 225 grams of benzene. Benzene is C6H6. And then the density, once I make this solution, the density is 0.876 grams per milliliter. Okay, so that's the information that's been given. I want the molarity, and I know molarity, big M, is the moles of the toluenes, the solute, divided by the liters of solution. So, the moles, these are the 2 things I need. The moles of the toluene is going to be the 5 grams divided by the molecular weight of toluene. The molecular weight of toluene will be 12 times 7 is 84, plus 8 gives me 92. So I'll do 5 divided by 92 to get the moles. Go ahead and do that. That's going to be 0.05435. So that number goes on top. 0.05435. Notice I always keep an extra digit or 2 when I do round off in the middle of the problem. If you round off to the correct number of sig figs throughout, it's going to mess your answer up, and sometimes you'll miss the problem because of it. Always keep 1 or 2 extra digits in the middle of the problem, or keep the whole number on your calculator, either one. All right, so the volume. I know the density. I need the volume, so density equals mass over volume. So the volume is what I'm solving for. I need the mass on top. Students will commonly mess this up because when I set up the density, this is the density of the solution. So on top has to be the mass of the solution, and the bottom is the volume of the solution. If they give you the mass or volume of the solute or the solvent, that is not what we're plugging into here. We need the numbers for the solution in this calculation. So on top, the mass of the solution is going to be 5 plus 225. Put those together, 230 grams of solution. To solve for this, I'm going to bring the volume up, bring the density down, so it's going to end up being the mass over the density. So 230 divided by 0.876 is going to give me a volume of 262.56. The units, density is grams per milliliter, so my volume is going to be in milliliters. And then over at my molarity, I need the volume in liters. So I'm going to have to divide that number by 1,000. So it's going to be 0.26256. So my molarity now will be 0.05435 divided by 0.26256 equals, that's going to be 0.207 molar toluene, which is C7H8. All right, so that's it for that problem. Now we'll move on to the next slide. Okay, so this is where we start getting into some of the more challenging problems. On the test, there will be some simple problems like what we've done, where I just give you some information and have you find a concentration unit. Where this gets harder is when I give you the concentration in one type of unit, I ask you then to convert that concentration into a different form. So I may give you molarity and ask you to find the mole fraction. I may give you the mole fraction and have you find the percent mass to volume, okay? Because at different times, the concentration unit you need for a given problem may not be what's available. So we have to be able to switch back and forth between them. It's really just a case of you have to be able to keep track of your units. You have to know what units they're giving you, know what units you want to find, and be able to convert in between. Okay? So, problem, well, we have a solution that's 36% HCl by mass. We want to find the mole fraction of the HCl in that solution. Okay? So the mole fraction of HCl, just up front, I know I need the moles of HCl on top, and I need the moles of HCl plus the moles of water on the bottom. Now, the problem never said it was water. It just said it's a HCl solution. But if you are not told otherwise, you will typically assume the solvent is water in general chemistry. When you go to organic, that may not be always be true. But in Gen Chem, most solutions we deal with are aqueous solutions. Okay? And if you don't know anything else, you have to make the assumption. So, I need to find this information. The starting point here is important, that I have 36% mass to mass HCl. So when I think about that number, 36% automatically to me, that means 36 out of 100. If it's mass to mass, it'd be 36 grams of HCl to 100 grams of solution. Okay? Now the key there is, like, I need to know the moles of HCl. I can't find the moles of HCl unless I kind of lock in a specific amount of solution to base all my calculations off of. Okay? Like, it doesn't tell me how big the bottle is that I'm using. Is it a 2-liter bottle or a 5-liter bottle or a 10-liter bottle? I don't know. So I just have to pick one. Remember, concentration is a ratio of solute to solvent. It doesn't really matter how much solution you have, other than the fact that we need to lock in our numbers. Okay? If they give me percentage, I'm going to look at the bottom. It's going to be 136 grams of HCl per 100 grams of solution. I'm just going to go ahead and lock in and assume for all my calculations I have 100 grams of solution. So assume 100 grams of solution. Now what that does for me is that it locks in. If I have 100 grams of solution, 36% of it is HCl. So what's 36% of 100 grams? It's going to be 36 grams. So I now know that I have 36 grams of HCl, and I had 100 grams. If 36 HCl, if I just do 100 minus 36, that tells me how much of the other component I have, which is water. It's going to be 64 grams of water. Okay? Now, from these two numbers, it's pretty easy to get what I need. I need the moles of HCl. Well, if I know the grams, I'm going to divide by the moles, divide by the molecular weight, which for HCl is going to be 1 plus 35.5. Essentially, I'm dividing by 36.5. That gives me the moles of HCl. For water, I'm going to divide by 18. That's going to give me the moles of water. Then I can just plug my numbers in over here. Okay? for shortness of the video, I'm going to let you finish that. When you get to the mole fraction and plug everything in, the answer is on the slide. It should come out to be about 0.278 for the mole fraction. Okay? Actually, I'm going to finish these numbers. I'm just not going to plug it into the mole fraction. So 36 divided by 36.5 equals, so it's 0.986 moles of HCl. And then for the water, it's going to be 3.556 moles of water. Now, the reason I wanted to write those numbers down is that I'm now going to, I'm assuming you can take those numbers, you can plug them in here and get the mole fraction. So we're done with that part of the problem. But the problem actually asks us to do two different things. It also wants us to find the molality. So we plug that in and find the mole fraction. I'm going to erase that for now. But what I don't want to erase, all the other information that I've already determined, I want to keep everything there so that I can use it to do part B of the problem. The molality is going to be the moles of the solute, which is HCl, over the kilograms of the solvent, which is water. So based on all the work I did for the first part, I actually already had the numbers I need to plug in right here. The moles of HCl, we said, is 0.986. Easy. And then the kilograms of water, well, I know I've got 64 grams of water. All I have to do is just switch that into kilograms, and I've got everything plugged in, 0.064. So now if I do 0.986 divided by 0.064, again on the slide, it tells me that the answer ought to be 15.4. I think that should work out. So now we go one more of these. On the next slide, tells us we have a bottle of nitric acid, and this is like if you buy a bottle of concentrated nitric acid, the density on the bottle, it'll tell you that it's 1.42 grams per milliliter, and if you look up the molarity, concentrated nitric acid is 16 molar. Knowing that information, can we calculate the mole fraction of both components, the molality, the mass percent, and the mass to volume percentages? We can. All the answers are on the slide, but let's do one or two of them. So let's say I want to find the mole fraction of water. Okay, so I know, again, I'm just picking one of the things we have to find. So if I want the mole fraction of water, that would be the moles of water over the moles of water plus the moles of nitric acid. All right, so let's go back to what we started with. They gave me the molarity. They said it's 16.0 molar HNO3. Now in the last problem, I made an assumption to start the problem where since I was dealing with percentages, I looked at the denominator and decided to start out with 100 grams because that matches up with the percentages. I'm going to do the same thing here. If I have molarity, that means it's 16 moles per liter. I'm going to assume that I have 1 liter. So assume 1 liter of solution. Well, again, that locks everything in for me, that if I have 1 liter solution, it's 16 moles per liter. So in 1 liter, I have 16 moles of nitric acid. That's key, that I now know the volume and I know the moles. They also gave me the density. The density is 1.42 grams per milliliter. So at this point, I need to start working. So number one, I need the moles of water over the moles of water plus the moles of nitric acid. The moles of nitric acid is 16. So I can actually just plug that in right here. It's going to be 16 moles of nitric acid in that spot. To get the moles of water, well, I know the volume of the solution. I know the density of the solution. If I know the volume and the density, I can find the mass of the solution. Now that'll be the water and the nitric acid together. But if I know how much the solution weighs, I could subtract, if I change the moles of nitric acid into grams, I could subtract that, the moles of solution minus the moles of nitric acid, to get the moles of water. So that's my plan. See if you can do it, but then I'm going to work it here. So my density is 1.42 equals, the mass on top is unknown, X grams of solution. But the volume, the milliliters, is going to be 1 liter is 1,000 milliliters. So if I solve for X will end up being 1,420 grams of solution. Okay? Now, that's the total mass of everything in the solution. I need to subtract the mass of the nitric acid. Now, I need to change moles to grams. So nitric acid is going to be 16 times 3 is 48, plus 14 is 62, plus 1 makes 63. The molecular weight is 63. So I'm going to do 16 moles times 63 for the molecular weight. It's going to be 1,008 grams. So 63 grams per mole. So 1,008 grams of nitric acid. So now the solution weighs 1420. The nitric acid weighs 1,008. So if I subtract those two, the grams of water is going to be 1420 minus 1,008. Is 412. Okay, so I have 412 grams of water, but I need the moles. So I'm going to do 412 divided by 18. So I got 22.889. All right, so I had 22.889 over 22.889 plus 16. We already figured out on the slide, it tells us the mole fraction of water ought to be 0.589. So hopefully that's going to work out. Looks about right. Okay, so that's mole fraction. Now let's just pick one more. Let's say it wants the mass percentage, which is letter C. The mass percentage, percent mass to mass. I know that that's supposed to be the grams of solute on top, which is 1,008. Grams of nitric acid. On the bottom, it's supposed to be the total mass of the solution, which we already figured out is 1420. And for mass percentage, it's the part over the whole times 100. And that's going to give you, again, on the slide, it tells us it's supposed to be 71% mass to mass. Okay, so again, once you do the first part, like we did part of letter A, we had to do a lot of work to set that one up and figure everything out. But then letters B, C, and D should be very quick problems because we already have all this information. Then it's just about picking and choosing what I need. Okay, so that's it for that. Let's move on. And actually, it's a good place to cut off the video for a new topic.